array queue looks like. But I want to now actually code it together. And we have just a few methods to implement. We're going to implement a constructor. We're going to implement empty. We're going to implement add and remove. And I've already added, we're going to uncomment this in just a moment, but I already wrote this method for us because this isn't really the focus of what we're doing right now. This is a grow if necessary method that will change the size of the buffer of the array. Now, in some applications, we could get away with doing this. In other applications, again, like allocating new memory is like really performance intensive. So this could like actually cause us to fall so far behind and get those buffer overflow errors. But this is here just for our own purposes. Um, so let's do our instance variables first. Um, I don't know why I have this comment here and I have elements here. I don't know. Anyway, so elements is a good thing to have. Um, Private object elements. Let's initialize this to, or we'll just leave it like that. So we do need an array of objects. That's going to be our buffer, our circular array. We need to keep track of the head of the queue and the tail of the queue. And we're going to do that by index. So we're going to say private int head and private int tail. And we need to keep track of the current size of the queue. So the array is going to be a fixed size. Maybe we have like 5 elements in the array, but the current size instance variable, current size, is going to be the number of elements in the queue, which will be less than or equal to 5, right? It'll be 0 when we start. There's nothing in the queue. Each time we add something to the queue, we increment it or we decrement it. This is needed because when there are certain positions of head and tail that an empty queue looks the same as a completely full queue. And so we don't know if the size is 0 or full unless we keep track of it separately. That's why we need this extra instance variable. All right, so let's initialize all these instance variables in our constructor, at which point we will have an empty queue. So public circular array queue, and we'll initialize each one of these. By default, let's make the size of our array 5 elements. So we'll say this dot elements equals, we have to make a new array of objects that holds 5 of them. We might as well start by saying the index for the head of the queue and the index for the tail of the queue is at index 0. Like the queue is empty. There's nothing in it yet. So we can say this dot head equals 0, this dot tail equals 0. And this dot current size equals 0, too. There we go. So when we're starting off, right now we have an array with 5 elements. There's no or room for 5 elements, an array of size 5. They're all null, right? So by default, when we make a new array of a class type, all the elements are initialized to null. We're keeping track of the index of the head of the queue and the tail of the queue, which is 0 because there's nothing in the queue yet. And our current size is also 0. Let's look at that picture again. Well, might as well make it big. All right. So we're going to implement empty. Well, let's do that first. Let's do empty first before we start doing the more challenging methods. So public Boolean empty. This returns true if the queue is empty. So we're going to say return this dot current size equals 0. There we go. So if the current size is 0, the queue is empty. That condition will be true. We'll return true. All right, now things get interesting. We want to add an element to the queue, which means we're going to add it to the tail of the queue. there are a couple things that have to happen here. Let's look at the picture. The index of the tail, the value of tail is an index. The value of tail is an index. Um, and so we know where the next element's going to go. It's going to go right in the array at that index. Um, and then we're going to like have to get ready. We have to move tail around and adjust the size and deal with all the instance variables. So we'll go through each of the instance variables in turn as we do this. Oops. Public void add takes one parameter, which is the element to add to our queue. We've seen things similar to this before. Because we're writing this queue such that the array, the circular array, can grow if necessary. So we're never going to have like a buffer overflow error. So first things first, we're going to call this dot grow if necessary. And again, like I already implemented that, we'll uncomment it. If our queue, if there isn't room to add the element, this will double the size of the array, copy everything over, and make it so that we can keep adding elements. Some applications that wouldn't be appropriate, we would instead check if there's room, and if there's not, we would like throw an exception. But in this case, we're gonna grow. All right, we have all the instance variables. So we're adding a new element. So we need to say this dot current size plus plus, add one to current size. Just double checking because the AP curriculum has changed a bit over the last few years. Do you all use and know the plus plus operator? Okay. All right, we have to assign a new element. So this dot elements, what index do we want? This dot tail equals element. So we've updated that at that particular index in our array. We have now stored a reference to the specified object. Now we have to deal with tail. So we're going to say this dot tail plus plus. We want to increment the index stored in tail. So after you type this, take 30 seconds on your own and think about what other code do we need to write to finish this method. I want you to focus on the boundary cases, right? Like not the normal case, but the case that only happens once in a while. So think on your own and then we'll discuss. All right, talk with your neighbor. What do we need to do? What do we think? What's the boundary condition we need to handle? We're going to get if we don't, so here's a clue. If we don't handle this, we're going to get an array index out of bounds exception. I think that's the name of the exception. The next time we add an element. Yeah, like, so right now we would move tail just down one and that's fine, right? So what are our indexes here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So tail would be 9. But when we increment tail again, it's going to be 10. Oops, that's going to be an array index out of bounds exception. If tail is 10, what do we want to change it to? 0. We want to wrap around. Okay. We've written code, we've written algorithms like this before. We could do this in so many ways. We could say if tail equals the size of the array, set it to 0. I think that is super clear. This is also always a good time to use the mod operator. If we like that approach, there's no one way to do this, but we could say this dot tail equals, or we could do mod equals. We could use the mod equal operator. This dot elements dot length. I think writing code like, you don't need to type this code, but I think code like this is more clear. If this dot tail equals this dot elements dot length, this dot tail equals 0. I think this is more clear. I'm sharing this approach because I think you'll see it a lot in other code. This shows up a lot in programming where this type of a boundary condition is often handled with the mod operator like this. Question? No? Okay. So remember, the mod operator is the value of it is the remainder, right? So think that that line of code that's highlighted is going to take the value of tail divided by the length of the array, and whatever is left over is assigned to the instance variable tail. So if tail is between 0 and 9 inclusive in our diagram, where there were 10 elements, if it's between 0 and 9, it's just going to, the remainder will be between 0 and 9, and it's just, the value isn't going to change. But when tail is 10, 10 divided by 10 is 1, we don't care about. Remainder 0, it's going to be assigned back to 0. Right. So this is how we often, you'll see this type of boundary condition handled in this way frequently. So yes. If it's full, it would, but so yes, here, let me show a picture. There's kind of two different things going on. Um, let's say when head is here and tail is here, and then we move it to here, there's still plenty of room in this array for new elements to be added here, here, and here. So we don't need to grow the array. We have space for additional elements. We just have to wrap the index for tail around to the top. That's a little bit different from head and tail are like right on top of each other because we filled the whole array up. In that case, we need to grow it and copy all the things and do that. But is that helpful? Okay. All right, let's write the remove method. Public object remove. It's going to remove the element at the head of the queue. We do need to support the behavior we've been supporting all unit, which is if it's empty, we want to throw a new no such element exception. What's that? I think in Java it's called add and remove. I think in other programming languages it's NQ and DQ. Maybe Python? So this dot current size minus minus, we have one fewer element. We need to like grab and store in a local variable what the value of that element is. We know exactly where it's going to be. It's going to be at index this dot head. We now need to increment head and still deal with the same wraparound condition. Here's another way that I've seen it frequently written. You'll see this dot head equals this dot head plus 1, and then the mod operator is used right here. So that's pretty common too. and then we return the element. So again, highlighted line of code does the same thing that we could write with an if statement, does the same thing that we did with a couple lines of code up above in add. So what this line is going to do is it's going to add 1 to head. And in most cases, let's say head has a value between like 0 and 8 out of the 10 slots we have. So if it was 0, it'd become 1. If it was 8, it'd become 9. We then apply the mod operator. So we're going to take whatever the value of head is, let's say 1, divide it by 10, and store the remainder into head. So the remainder of 1 divided by 10 is 1. If head was 8 and we added 1, we're up to 9. The remainder of 9 divided by 10 is 9. Like nothing's changing. But if head was 9 and we add 1 more, so now it's 10. 10 divided by 10 is 1 with a remainder of 0. So that's going to basically reset head to 0. So this line essentially allows for the wraparound. Mm-hmm. Yeah, so we have a wraparound example here. Add, we took a slightly different approach, but I just wanted to show you multiple ways. You can do it in one line like this with the mod operator here. You can do it in 2 lines like this with the increment operator and the mod equal operator. I don't know what to call that. You could write it as an if statement. All of those are valid ways of doing this. And then we can remove our comments here. And we have a fully working program. You could switch over to Q demo and uncomment the demo code now that we've written everything. And you can see here in the demo code, we're adding to our circular queue, Tom, Diana, Harry. We're removing Tom, head of the queue, adding Romeo, removing Diana, adding Juliet and Maria. 1, 2, 3, 2, 3, 2, yeah. And then we just write our standard loop while the queue isn't empty, just remove everybody. So you can actually see it go and check that the output is as expected. So